So hello everyone. So our today's LeetCode question is 143 reordered list. So basically what this question is, first I'll go through it. So this question says that we are given a linked list. Suppose it's given 1, 2, 3, 4. So now what we have to do? We have to rearrange it. So rearrange it like this. The second half of number should repeat after this. So 1, then 4. Okay, then this first half element will come 2, then the second half element will come 3. So likewise this L0 L1 L0 is C is there, L0 L1 L1 n minus 1 L2 n minus 2. Okay, so zeroth index, last index, first index, second last index, third index, last third index. Okay, so likewise this, it is given us to solve it, to rearrange this. Okay, so 1 2 3 4 5, what will be our new reordered list? It will be 1 3, then 1 5, then 2, then 4, and then 3. So likewise this, it will be get reordered. Okay, so my approach to solve this question was simply, when it struck my mind. So see, this is of today's only, and I did around 15 attempts from runtime error to time limit, then wrong answer. Then after wrong answer, I got confidence and I was able to make it. So my approach is to initialize stack and queue. Okay. So after initializing stack and queue, what I did, put the first half of the linked list element in the queue and put the second half of the linked list element in the stack. Okay. So come to uh, this picture. So what I did, 1 2 3 4 5 6 7, 7 elements are there. So what I did, I put first 3 element in the queue, and last second half element in the stack. 7 6 5 4. Okay, sorry, 4 came first, then 5, then 6, then 7. Okay, likewise this. And what I did, my main focus was to put this middle element also in the stack alone. Okay, so this was my approach. So okay, after doing this, I used using middle of the linked list question approach, which is this question approach, to put the to sort the element first half into the queue and second half in the stack. So I have used this approach, these two pointer approach, slow and head approach, to solve my reordered list question. Okay, so after this, what I did, what I did, I tried to insert the element one by one. Then this, see, this one came from queue, then 7 came from stack, then 2 came from queue, then 3 came from then 6 came from stack, then 3 came from queue, 5 came from stack, and then 4. Okay, so likewise this, I have solved this question. Okay, I hope you have understood this my approach, and in the end I'll return the head pointer. Okay, so now let's start our question. So our question, first of all, I'll show you one thing which I did in my approach. Remove this question because we don't need it. So I am first of all resetting it. So here you can see that it is void is given, so we don't have to any return any value. So what I did, I altered it. I changed it to linked list node. Okay, why I changed to linked list node? Linked need a pointer data type, because I want to return the value. This is my approach. It can be your approach, any approach. So yeah, what I did, I changed from void to linked list data type, and you can do it. It doesn't matter. Okay, this is for beginner people who are new to the coding. You can implement this. Okay, so likewise this my step which I discussed, initialize the stack and queue. I have initialized the stack and queue, and using middle of the linked list approach, where slow pointer and fast pointer is there. So what I did, using this approach, I pushed the element in the queue, because I know with this middle of the linked list approach, I can sort all the first half of the element 1 2 and 3. Okay, so I put all the element in the queue. Okay, by this approach. Okay, and rest of the element are left after the middle, considering middle element, which I put it in the stack alone. Okay, So I'll explain you this part. If you haven't got it, I'll explain it. No worry, don't worry. I'll I first skim through my code and then explain it in bit by bit. Okay. So yeah, for that, please do like and share and subscribe. Like and subscribe are most important. Please hit that button. It gives me a big booster, big confidence to make the videos for you. Okay. Then what I did, I tried to insert all the element in my linked list, which is having head pointer. Okay, so what I did is I popped my first element in the queue because it is already in the head. So suppose head is one, and linked is and queue is also one, so we don't need it. So first element I popped it from the queue because I don't need it. I have gone to the second pointer address. Okay, so what I did, I I am sorted with this part. Okay, I am sorted with this. Now I want to come to 7. Okay, stack. So I'll insert this 7 into my linked list. Okay, 7 into my this linked list. So what I did, head value is equals to stack dot top. So I replaced the earlier head value which was 2 with 7. Okay, this 7 approach. Okay, and then I popped 7. So this element will pop from stack. Now 6 will left. Okay, and 6 will left. So now what will happen after this? I want to insert, after 7 I want to insert 2 of the queue. Okay, so for that I did head value is equals to queue dot front. Okay, then pop the queue. Okay, so I have popped the queue. I've popped the queue. Now what will come? 6 will come. So from stack I'll put it in the new link, into our existing linked list. Okay, 6. So what I did, after pointing head to head next, we again come to while loop. We'll check stack is not empty, queue is not empty, or queue is not empty. Then we'll go through this. Then we'll put head value equals to stack top, which is now 6. Okay, 7 we have popped out. Now 6 is there. So we have put our head value, pointer value as 6. Okay, then we'll pop it out 6. So we'll pop it out 6. Now what will remain? 5. Okay, so we will come to our queue, and queue, in that queue we'll put 2. Okay, because sorry, we'll put 3 because 1 and second are inserted, then 3 is left. Okay, so we'll put head value is equals to 3 and we'll pop this queue. Okay, so now we'll point to our next pointer address, head is equals to head next. Okay, now we'll see that this part queue has become empty, so now this has no value. Okay, now we'll check stack. If a stack is not empty, then we'll go through it. Okay, so now stack is not empty, we'll check stack dot top, which is, what is stack dot top? 5, because 5 is remaining after 6 is popped out. So we'll assign it 5 and then go to the next point, next header, and this loop will not work because all the element of 1 2 3 are popped out. So we'll go through again. We'll check stack is not empty because there is one element left and our queue is empty. This will not grow because of the priority. So this is not empty, so we'll again run it. So head dot value is equals to 3. Head dot value is equals to 4. Okay, so 4 is there. So now stack dot top is equals to 4. We'll pop it element, we'll go to next pointer. Okay, we'll go to next pointer. Now this comes in place. Now this comes, so it will say if head is equals to null, because head dot next value, see this part 4, head dot next is equals to null, so here only it will return it. Okay, okay, here only it will return it. This is the most important part. Listen, see, this is our last part. Okay, this is our stack part is there. Okay, stack dot top is equals to 4. Okay, this is 4, which is our last element in our updated linked list. 4 is there. Okay, so 4 is there, we popped it out, and we'll point head is equals to head next, which is null. So if head is equals to null, we'll return head. Okay, so what is head? It is our initial we'll return a head. It is our initial, what can I say, it is our initial address to our pointer. Okay, okay, so it will return head. Okay, so this is the most important part which you don't have to follow, which you have to follow. Okay, so it will return it. Or so this was my approach to solve it. Okay, so this is how I solved it. I'll explain it again. If you didn't got it, I created stack queue, put half of the element in queue, put half of the element in stack. Then I took out one element from queue, one element from stack, one element from queue, one element from stack, one element from queue, one element from stack, until queue become empty or queue stack become empty. Or if queue become empty, then I'll go with the stack, and eventually stack will also become empty. So this was my approach to solve this question, and this was some of the optimizations which I did in the code. If head is equals to null, return head. So these two are my what can I say, expression which I use to avoid runtime error. So these all runtime error are occurring because I didn't use this head is equals to null, return head, because here it is most important part na. Okay, so this was my approach to solve this question, and I hope you like it. Please do like and subscribe. It gives me a lot of confidence to make more such videos. And if you didn't understood any part, you can go again. You can go backward in the video and watch it. And if you have come this far, then thanks for watching it, and bye bye. That's all for today. Thanks for watching.